Hey guys, welcome back to my channel, and today we'll be talking about the difference between the area under the curve and a definite integral. Now, definite integrals will help you find the area under a curve, however, that's not always the same thing, and you have to make a distinction in how you find your area under the curve. And I apologize for any background noise, there's currently a really big storm outside, but let's get going. So what is a definite integral, just as a recap? Well, a definite integral just tells you what the antiderivative of a function is. But if you view this as the area under the curve, it will also include a negative area under the curve. So if I want to take the integral of this, using a definite integral, if I just say definite integral from a to b here, what will actually happen and what I will find, or what my calculator will find, is that it's going to give me the red area minus the orange area. However, when we're talking about the area under a curve, this is wrong, and we want the red area plus the orange area. So that's why you can't always rely on simply going from a to b, and sometimes you have to split your definite integral into a couple of parts to figure out how to get the actual area under the curve. So the area under the curve is therefore, if we look at this, the absolute definite integral, and we can denote it as following. Now, this kind of notation can help us remember that if we just use a definite integral, that we're not always going to get the correct answer. However, it doesn't actually specify what we have to do in order to get the correct answer. And the method for this is basically to split your function into a couple of parts so that in the end you get this red area plus this orange area, and not minus the orange area. And let's think about how we can do that. So just take a minute, try to figure out what would you do to find the area under this curve, assuming that this is our initial point, A, and this is our final point, B. Well, in order to find the actual area under this curve, we have to recognize that our working out, or our math, will give us an area over here which will be positive, and an area over here which will be negative. But here, at the x-intercept, there's a change in the signs of the integrals. So we have to split the function so that we first figure this out, and then we figure this out, but take the absolute value of this negative integral. So let's call our x-intercept c, and the first step is going to be finding all of our x-intercepts. And so now we can actually split our definite integral into different parts, so we can split the negative parts from the positive parts so that in the end we can all add their absolute values. So in this case right here, I would do the definite integral from a to c of f of x dx plus the absolute value of the definite integral from c to b of f of x dx. And the reason why I didn't put the absolute value over here is because I already know that this is going to be positive because our y values here are positive, but here I have to account for the fact that this area will initially be presented as a negative value and take its absolute value. And so this is going to be the total area. And this is different from the definite integral because the definite integral, again, can be negative. It has anything that's below the x-axis is a negative value. And so you're going to mess up your result if you simply ignore the fact that there's an x-intercept from where the function goes from positive values to negative values. And again, just for conceptual understanding, that's simply because the definite integral is basically your y value times the instantaneous change in x, so dx. So if your y value is negative, your definite integral is also going to be negative. So let's do a quick example. And this is a very simple one, but I think it will get your understanding better. So this is a function which is y sine of x, and I graphed this on Desmos really quickly. And so actually, let's say that we want to find the area from 0 to 2 pi. Again, we're working in radians. And if you want this area, but you just type into the calculator the definite integral from 0 to 2 pi, you're going to get 0. And this is exactly what I did to show you. But when looking at this graph, you can obviously tell that the area is not 0. But the problem is, by taking the definite integral, you're finding this area right here, and this area right here. And since this is sine curve, they're actually equal to each other. But what this definite integral does, it ends up adding the green, and it ends up adding the purple, but the purple is a negative value, which in the end gives you 0. So now we understood that. Let's actually get to it and how we find the actual area under the curve. So as we've said before, first let's find our x-intercepts or our roots. And sine of x is equal to 0 when x is equal to 0, and when x is equal to pi, and when x is equal to 2 pi. And so we can see here that this is our pi, and so we're going to split our definite integral based on this value of pi. So our positive definite integral would be from 0 to pi of sine of x dx, and then we have to add the absolute value of our, so to say, negative integral from pi to 2 pi of sine of x dx, right? And again, we're just accounting for this negative area that the purple area would give us. And so this is going to be equal to the integral of sine of x is negative cosine of x from pi to 0 plus the absolute value of negative cosine of x from 2 pi to pi. And so this is going to give us negative cosine of pi is -1, so -1. Negative, and then cosine of 0 is 1, but it's negative cosine of 0, so it's -1. Plus the absolute value of the cosine of 2 pi is again 1, but this is the negative. And then minus, and the cosine of pi is negative, but negative cosine, the cosine of pi is -1, but negative cosine of pi is +1. And so this is going to give us 2 plus the absolute value of -2. And again, this is why we got an answer of 0 right here, because this area is equal to -2 and this area is equal to 2. But really this is 2 plus 2, which is going to equal to 4. So our total area here is 4 and obviously not 0. So I hope you enjoyed. I hope you got a bit more of an intuition for this and you understood why you simply cannot plug numbers into a formula sometimes, because you might end up with a mistake like this. So I hope you enjoyed and see you next week.